All right, so in this problem, I'm going to be going over how we find the distance between these two parallel lines. So start with a sketch because you want to get a picture that kind of gives you a good idea of what this would look like. And so let me see what I can do. Here we go. That's our y-axis. That's our x-axis. Okay. Now these are two lines with slopes of -5, so they're going to be kind of going like this. So make sure you have the proper tools when drawing your graph. So we have one going at a y-intercept of 1 and another at -14. So let's do this. Let's go like that. This other one will be like this. Go a little further. All right. So this will be, let's call this point A. And point A is at 0, -14. 0, -14. And we'll call this point B, which is at 0, 1. And this is line, this is y2. And this line is y1. Yeah. Okay. Now, make sure that you don't draw your graphs in the wrong direction, because if you draw them in the wrong direction, you're kind of screwed for the rest of the problem. So don't do that. They're parallel, and so there's more than one like possible line segment that you can calculate to get the right answer. So I can have a line segment that goes like this, or I can have a line segment through B, or even another one to just, all by itself, all yonder, But be efficient about it. So I would pick a line segment that goes through point A. And the key is to make sure the line segment is a perpendicular line segment, meaning it makes a right angle. And don't just draw it to make a right angle. Make sure the math backs it up. So we're going to call this line Y3. Let's see if I have another color for Y3. Really, it's blue mark. Okay. So we need to find the distance from this point to this point. We'll call this point C, So we want to find the length of line segment AC. That's the ultimate goal. We want to find this line segment. To do that, we have to find where C is first. So let's make a little note. Find point C and the idea is to understand that point C is going to be, not going to be, it is point of intersection. It's a point of intersection of Y3 and Y2. So to figure out where C is located at, you're going to set Y3 equal to Y2. Now we have to figure out what Y3 would be. So the equation for Y3, though, would have to have a slope that's the opposite reciprocal of Y1 and Y2 because it's a perpendicular line. So Y3 would have a slope of positive 1/5 because the opposite reciprocal of -5 is positive 1/5 because -5 is the same as -5/1. Flip it, change the sign. And since it goes through with this point 0, -14, the y-intercept is just -14. So we're good there. Now we go ahead and rewrite this as 1/5 x minus 14 equal to y2, which is -5x plus 1. And now we solve for x. Let's add 5x to both sides. So 5 1/5 x. Let's add the 14. Let's rewrite this as 26 over 5x equal to 15. Let's not forget our fraction math. Cancel the 26 over 5 by multiplying by 5 over 26. Bang, bang. X will then be 5 times 15, 75 over 26. I'm going to leave it like this because I like to be precise, because that's how you accomplish greatness in life. So I'm not going to round it to a decimal. Now, that's just the x-coordinate of point C. We need to find the y-coordinate. The y-coordinate can be found just by plugging this into either y2 or y1, because it's going to give you the same value. So plug it into the one that's more efficient. So I'd probably plug this into, I like this guy. So I'm going to plug it into y2. So -5 times 75 over 26 plus 1. 5 times 70 is what? 350 plus 5, 375 over 26. -375 over 26. Plus 1, we're going to change that 1 into 26 over 26. Come on. And then we will get the -349 over 26. All right. So what does that tell us? It tells us that point C has this y-coordinate and this x-coordinate. So then, where should I write it? So C that, let's go over here. C that 75 over 26, comma, -349 over 26. I don't know why I switched the color, but whatever. Actually, I'm going to switch back to red. Now, point A, remember, was at 0, -14, because it's right there. So all we have to do is find this distance. So then we have AC will be equal to, remember the distance formula. Distance formula is the square root of x2 minus x1 squared plus y2 minus y1 square, all underneath the square root. So we can call this x1, call this y1, call this x2, call this y2, it doesn't matter. So let's go x2 minus x1. So 0 minus 75 over 26 squared plus y2, -14, minus -349 over 26 squared. Yeah. Okay, so this ends up being -75 squared, which is the same as -75 squared, or which is the same as 75 squared, over 26 squared, plus let's change this 14 in terms of 26. So then we can combine it. So 14 times 26, 364. Okay. This is negative 364 over 26. So negative 364 minus minus. So over here it becomes negative 364 plus 349 over 26. Using fractions, so then we have 15, or negative 15 over 26 squared over 26 squared. Come on, come on. Well, even for it to look so messy. Over 26 squared. All right, one more hopefully. So then we go square root this 75 squared, 5625 plus 225. So 5625 plus 225, 5850 all over 26 squared. The square root of 26 is just 26, or the square root of 26 squared is just 26, duh. And then we have the square root of 58 over 5850 on top. And we can take a decimal approximation. And we will get, where should I write it? I'm going to write it over here. 2.941742027 units. Okay, there you go. So again, I'm being as precise as possible, which I recommend. But I hope that helps. Let me know if you have any questions, and I'll see you guys in the next video for the distance between a point and a line.